Okay, so p-chem. Woo, here we are. How about that? Okay, it's definitely the most hated course in the chemistry curriculum. I know that. Okay, that's why there's a bumper sticker. All right, so even the ACS for years had offered this bumper sticker that said "honk if you pass p-chem." All right, so we have one now. I made an SHSU branded one, and so when you get through this fall semester, successfully, then you get your bumper sticker that you can put on your car, or on your laptop, or whatever, that says "honk if you pass p-chem." And if you see somebody in town, which you occasionally will be at the stoplight, and there'll be somebody there, and I always honk. It's one of my students, right? Everybody else is like, "Oh my, this is Texas." When you honk, it's really rude. It's like, "Oh, someone honked at me." Yeah. So let's talk about p-chem. What is it? Well, it's not really this. Okay, this is from Ant-Man and Wasp. The quantum realm. All right, so this real trippy place. But we will talk about this quantum realm a lot. That is the interaction of light and matter. Okay, so light comes in, interacts with subatomic particles and so on, and light is really our tool for understanding what's going on in that atomic scale. There's really no other probe that we have. We do have atomic force microscopy now that can actually tap the surface. You can take a little silicon chip and dissolve it slowly, and it'll get an atomically sharp tip, so like one atom on the end, and you can get that atom close to the surface and measure the electronic current. And when it gets close to the surface, you'll start to see a little current jump as electrons tunnel through the gap. And so you don't have to actually touch the surface, but you get close enough to measure its roughness. And since you have an atomically sharp tip, you can measure single atoms. And so we actually, in the 70s or whatever, IBM pushed around xenon atoms on an atomically smooth nickel surface and spelled out IBM. So you can go see that on the web. And so that's our we've seen atoms. Okay, so definitely nature is particulate, but then it behaves like waves too. So particles should be able to have any energy, right? You put a ball on a ramp, it can go anywhere on that ramp, it can have any energy. And so that would be what we would call classical physics. And so in this first part of the course, we're going to contrast classical physics and the failures of classical physics with quantum physics. And quantum physics would be like stairs. So if you have a ball on the stairs, you can put it on discrete stairs, but you can't have it in between the stairs. And so why would nature be quantized? How can we figure that out? Well, waves are quantized. If you think of a guitar string, you can strum it and it has a particular tone. There's a particular waveform. If you touch it halfway and pluck it again, you get a node in the middle and it goes up an octave. Okay, and so you can't get a note between the octave and the fundamental. The string won't vibrate that way. It will either vibrate the whole string or half the string or a third of the string and so on. And so you set up these standing waves. Uh-oh, I need to plug in. Panic. This computer has a lot longer time on this. I don't jinx myself, sorry. All right, good. Okay, so the standing waves were proposed by de Broglie, and we'll talk about that later. So this idea that nature is wave-like in properties, that was the birth of quantum mechanics in the quantum realm. Quantum just means like a small packet. Okay, that's all that word means. So discrete units, so like stairs. So whenever you think of quantum, just think of stairs. So nature it's really strange. Why would nature have discrete stairs of energy? It's because nature is behaving like a wave. And so light's behaving like a wave, all of nature is behaving like a wave, and so we're talking in this whole course about how these waves interact. And so it's really a wave mechanics class. So we cover an incredible distance scale. If you stay through the whole second semester, in p-chem 2, we get into thermodynamics, and we talk about energy scales in the terms of 10 to the 18 joules. So world energy use is around 425 exajoules in energy. So you've heard of mega and tera and all these different large, megabytes and gigabytes and so on. When we get up to exajoules, that's 10 to the 18 joules. So that's sort of the the energy scale of the whole globe. We get into the micron scale. The smallest visible particle with good vision would be around 100 microns. And then we get into the quantum realm around the nanometer range. So 10 to the minus 9 meters, roughly the diameter of a buckyball, the little soccer ball of carbon. And then the bond length of a hydrogen would be an angstrom. So we deal with angstroms a lot. Those are our bond length units, 10 to the minus 10 meters. And then the smallest energy, essentially in terms of a chemical bond, would be a single hydrogen bond at 10 to the minus 21 joules. That's a zeptajoule. Okay, so they have these prefixes for every 3 powers of 10. So we are covering, think about the range from minus 10 to the minus 21 joules all the way up to 10 to the 18 joules. So this course covers an enormous amount of energy in terms of, let's see, 21, 30, 39 orders of magnitude in terms of energy. Now, this course, many of you got into chemistry because you liked the periodic table, or you liked molecules, ions, and so on, and that's great. You liked organic because you're dealing with all the reactions and everything. And then you get to p-chem and you're like, where are the chemicals? You know, we're dealing with electrons and waves and light. And so it's much less chemical in the sense that you're dealing with reactions and so on. We're not dealing with so many of those reactions. So that's another mindset. And so I really want you to try to focus on the newness of this material and generate some curiosity in it. So what do you think this quote by Da Vinci is saying? That's Da Vinci, by the way.
Maybe that if you study but you're not interested in what you're studying,
it just doesn't stick, right? So that desire, that interest, what you're saying is so true. So I can't say that you have to love p-chem. I would love it if you did, right? But you've got to find something about the material that is interesting to you. Okay, some of you like math. Well, good. You're going to get into some math on this one. Some of you hate math, so maybe that's not the thing that interests you. But what is the math telling you? The math is applied in this class. You know, I didn't like calculus either. When I took calculus, it was like going to an auto repair shop and then pulling out a torque wrench and saying, this is a torque wrench. They use it to torque bolts, and then they set it back in the tray. And they said, and this is a spanner wrench. You know, you do this, and it opens up, and it can open rings and get them off of this thing, and then you put it back in the drawer. You learned about all the tools, but you never really used them in a practical application. And that was, you know, when I got out and then I got into p-chem, I was like, oh, wow, the calculus can actually do something for me. You know, I was actually applying the calculus to something I really liked was chemistry. And so hopefully that will be your experience, or maybe you just love the math. So whatever you find that's interesting to you, lean into that, because that will help you remember the material. Okay. If you're here for a grade or to get your degree, those are long-term goals. That won't help you remember the material. Think about going to a movie that you like, whatever, if you like Marvel movies like I do. You go in, you come out, and you and your friends are quoting almost whole paragraphs of text from the show, from the dialogue. And you never read a word of it. You never studied any of it, but you can remember it because you liked it. Okay, emotion is the save button. Okay, and positive emotion is a really strong save button. So if you can find something that you like about the material, it'll stick a lot better. Okay, beware of, this is a little storyteller doll. Okay, we're in Albuquerque, New Mexico. It's one of the great things in the gift shops there. So beware of the p-chem storytellers. Okay, has anybody heard any nightmares about the course? Yeah.
I did. I was actually talking to my doctor when she asked what classes I was taking, and I told her I was taking p-chem, and she told me that she was going to add a chemistry minor to her degree plan since all she needed was p-chem, but then everybody told her how horrible it was, so she didn't do it.
Yeah, and that's coming from a doctor. Right? I mean, you can imagine that coming from just, you know, some Joe in Starbucks or whatever. They're like, oh, p-chem, you know, that's why I went into business, right? But a doctor, You know, you're like, ooh, and I get that a lot too. Oh, you're a chemistry teacher. Wow, what kind of chemistry you teach? p-chem. And they always go, because they're more biology focused. They're, medicine and so on. So I get that a lot from doctors. Yeah. But it can be hard. I think that I've tried to make a path through the course that's very doable. And then also the videos really help. And so we'll get into some of the plans for when you have trouble. What do you do? Okay. The worst p-chem story I heard, one student told me in my office hours. She said her friend told her that, well, you just have to expect to fail it the first time, so then you take it the second time and then you pass. That is not true. Okay. Yeah, that is not true. That was just her friend telling her that, who had failed it the first time and was taking it the second time. And so a lot of times whenever someone tells you they've been through something, they always want to make it sound worse than it was because that makes them better, right? You ever talk to a duck hunter? Oh my gosh, it was so cold and it was so wet and all this business. Or talk to a runner or a hiker, the mountains were always taller and the trails were always rougher. And p-chem was always harder. And so beware the storytellers. It's not that bad. Okay, where are you and where will you move to? Okay, so this is a 2x2 grid. Okay, I can and will do it. Those are my people. Okay, these are my people too. I can't, but I want to. Okay, these are not my people. I can, but I make poor decisions, or I can't and I won't try. Okay, so I want you guys to move to the top. Okay, say I'm going to make good decisions in scheduling my study time, and I'm going to try. Okay, and if you get up to the top row, I can do what I can to help you move over to the can and from the can't. Okay, but the getting off that bottom shelf where you won't do it, or you keep cutting your legs out from under you because you got to watch your show tonight. I know I got to study, but my show's on. They DVR the whole thing and watch it over the Christmas break. We got like 6 weeks. Okay. So that'll be your reward. Now study the syllabus. Whenever there's a conflict, the syllabus beats Blackboard. Unless I come up with something that the syllabus needs to be revised, I will revise the syllabus, but I'll put a little change log in there. And it'll be on the syllabus in the header or the footer, and it'll say new revision, fixed to conflicting language or whatever. So now the first homework assignment is due this Saturday night at 11:59. We got a whole week. Sometimes we started on Wednesday, and it was like a big shock. So it's just on the first bits of the course, a little bit of history and just some like warm-up calculations, converting wavelength to frequency and frequency to wavelength and energy. So how do we do the homework quizzes on Blackboard? Well, we want to work to understand those terms and answer the multiple choice problems. There's numerical problems where you enter in your number. I put about a 5% flex on there, so you don't have to have exactly the same rounding that I do. So I tried to say plus or minus 5% for rounding errors. Now, scientific notation is a little tricky in Blackboard. They just take the 10 raised to the power or whatever. They just put an E there. So you can type in, if you get a number that's big or small, you can type in the scientific notation in Blackboard, but you just, like for Avogadro's number, you type in 6.022 E plus 23, and it will register that as a scientific notation number. So that's an important thing. You get a couple of attempts, so don't waste them. And the last attempt is the one that goes into your grade. Don't cheat yourself. If you really don't know why it's right, then pretend it's wrong. Okay? Getting it right isn't getting the right letter or the right number. Getting it right is knowing why it's right. Because I'll change it a little bit on the test. If you don't know why that was right, then you won't be able to answer the question on the test. And the test is worth way more points than the homework. And so you want to know why it's right. And that's a great question to ask in class. Say, hey, I got this one right, but I don't really know why. And so can you explain this question or this problem? There's a Quizlet vocab study tool that's been made by my students. They went through this whole long list of words that I put up, and and they built it out pretty well. So go on to Quizlet, set up an account if you want, and then you can search for my online name, Chem_prof, and I'll let you into the course, and everything will be good. And then there's Kahoot study quizzes too. We'll do some of these in class. If you'll search for Chem_prof and type in 4448, you'll get all of the Kahoots for this course, and they're like the main points in any given lecture. The lecture numbers may not line up exactly. Like these say L24, L31. Those are supposed to be lecture 24 or lecture 31, but they might be slightly off. I changed the schedule slips a little bit forward or backward, depending on the semester. And then here's how you find me. You can leave me a voicemail on the 294-1529, and it'll come up on my phone so I can read it. Speak slowly, and the text-to-speech will pick it up, and I can read it. I can respond back that way. You can email me. I prefer the email. Email acts as my inbox, so it'll stay in my inbox until I clear it out and get to it. I may not get to it the next day, but I'll eventually get to it. If at all you're curious about my research or anything like that, the pchemforall.com is my science blog. And then I accept all social media connections, but there's nothing class related on that. So don't worry about not being on my social media. I'm not going to make class announcements on Facebook or anything like that. So everything will come through here or through Blackboard that you need to know. Sometimes the students set up a group me for communication, just checking in on deadlines and stuff like that. I don't manage that, so y'all can do that on your own. I don't care about that. Don't share answers on it, though. Please, you're really hurting yourself if you try to use group me or whatever to get the answers for the homework. Again, you're going to just get run over by a truck when it comes exam time. Wow, you got the 10 points for that weekly homework. Good for you. And then I see 20s on the test, and I'm like, oh no, this is not a good thing. Yeah. Yes. Yeah, my office hours will be on Zoom, so you can do it from wherever you are. Okay, I even had a last semester a fellow that came to my office hours quite a bit, but he was working in the rec center at the climbing wall, and so he was on the clock, but also at my office hours. But nobody was on the wall, right? And so he's like, well, I'm going to go ask DW this question, and so I could see the background. I'm familiar with the area, so I was like, all right, I know where he is. Yeah, so that's convenient, and it'll be good. So, but you can still come to my actual office if you're in the building and you just want to run up and ask a question. That's fine. Yeah. So how's the course going to be organized? Everything, of course, is on Blackboard. The syllabus, we have the syllabus link. This will be the latest version of the syllabus. I put a date in there to show the revision. In fact, from the time this was screenshotted to now, there's an 820 version of the syllabus. I can't remember what I changed, but anyway. So the latest version is 820. Here's the link for the office hours Zoom. Right there on the syllabus thing, I put it right here. I think I also put it on the weekly schedule page too. So you have a couple of places. I have it right after this class, 10 to 11. But don't let that restrict you. Like if you have class in the next hour, just send me an email and say, can we do a Zoom this afternoon or something? Sometimes your lab time, if you get started on the lab and you want to see if I'm available, you can call me or whatever and run up and ask a question and run back down if it's something real quick, or email me. The more specific the question, those can be answered by email. So even if it's on a problem, show me what you've done with your work and say, I'm not understanding why this isn't working out. Then I can see what you've done and I can reply real quickly. Those are the ones that I can get to right away. If it's just a generic question, I can't really answer. I don't know what the problem is. There are dumb questions. The dumb question is, I don't get it. That's not nearly specific enough. So what don't you get? Like, is there a vocabulary word that you're stuck on? What's the sentence that's confusing you? Try to drill down to the thing that you don't get. It's really common not to get something, but you got to drill down and give me information so that I can help you. Okay, weekly schedule. So they'll put everything in a weekly schedule folder, so every week has its own folder. So in that folder is everything you need to know about that week and what you need to do. Okay, so this is hopefully, I really tightened up the organization of the course during COVID because everything else was falling apart. So I thought, okay, I'm going to try to get everybody into one folder each week. This is what we're working on. And so everybody liked that, so I kept it. So here are the 3 lectures for this week: semester overview, Excel bootcamp, and the syllabus. Then sort of a history lesson on quantum mechanics, and then we're going through all of the messy math of how light interacts with matter on Friday. So don't miss Friday. Fridays are not optional. Okay. And so my freshman class, I used to track the attendance and it would go Monday, Wednesday, Friday, Monday, Wednesday, Friday. And they would take Fridays off and just fail hard. And so anyway, p-chem's less of that. Y'all gotten your dumbs out. So yeah, this week 1 folder, you click on that, then you get this material here. So here's what you need to do this week. Read the syllabus, buy the materials, print the PDF lecture handouts. I know that, can I see a show of hands of the folks that did not do the Bearcat bundle? Yeah, see, there's a lot of people last semester too. And so I was going with the top hat because it was in the Bearcat bundle, and then I realized so many people didn't do the Bearcat bundle. And so we're really not doing top hat this semester, okay? If you have the Bearcat bundle and you got it, there's no extra cost because it's all in the bundle. But for those who are not in it, don't go buy it because we're not going to use it. We'll use Kahoots, and we'll just go back to that because I'll keep my comments on how they rolled that out to myself. Then so that's why I say buy the suggested materials. It's really just the book, and you want to buy the book to have in your library. Now there's different versions of the book. You can have it on Kindle or what have you, but I think you're building your library through this degree, and then when you go into industry, there's a whole lot in the course of that book that we don't touch on. And occasionally you run into a situation where you need to go back to that book and look up the physics behind the chemistry that you're studying. And so that's a good book for reference. Then Wednesday we have the lecture handout. We'll see some more about the lecture handout in a minute. And then I've been not quite finished, but 95% finished with my book. So 2 years ago in April, I got a call from a publisher that gave me a contract to write this p-chem book as a supplemental. And it's essentially how I teach p-chem here at SAM. And the due date is September 16th. Okay, so it's in review. Like I'm sending it out to friends and other scientists to say, hey, look for typos and does it flow right? Does it teach well? And so I've got the chapters here at the relevant places. And so right here you can see chapter 1, and it's my co-author is a former student. She did her master's here, and it's on the first 6 weeks of this course. So this will be a really good book if you had it in the summertime to read before you take the course. So that will be the goal in the future, is to be a supplemental like summer reading thing. It's not a lot of hard reading. There's a lot of calculus in it, but it's step by step. I don't skip any steps. And so you could read through that. We're going to do that calculus in the second lab, the calculus week, kind of like Shark Week, but calculus week. And so you'll go through the calculus, and then you'll do an exercise on using equation editor in Word, and you'll turn that in as your report on how to introduce an equation. And one last thing, those that come in a little late, come up and sign the roster. You won't interrupt me. Okay. So I saw someone else come in too a while ago. Okay.
Sorry about that.
No problem. So the chapters will be available for you to kind of understand in more detail what I'm teaching, because it's not in your textbook. That's the reason I'm writing a book.
I think I'm in the wrong class.
Okay, good.
Have a good day.
Yeah, you too. Hope you find where you're going. Yeah, so a lot of the students were complaining. They're like, where is this where are we in the text? Well, years ago when they instituted the Common Core, and they beefed up the Common Core classes, and then they reduced the total number of hours you could require for a degree to 120, the curriculum got squeezed, right? So they had to have extra, social studies course or history course or whatever, And so that squeezed us from below. And then from the top, capping the hours at 120, some things had to go. And that third semester calculus had to go. And you may say, yeah, all right, yeah. But then when you get to p-chem and you're trying to integrate a volume like the hydrogen atom, you got to do a triple integral. You got to integral with respect to distance from the nucleus and respect to longitude and latitude, r theta phi. And so that hurts. They took that multivariable calculus course out, okay? And if you're getting a math minor, you can take it. That's great. But I was kind of harmed in this course because how do I teach in three-dimensional integrals when students have had one-dimensional calculus? So that's why we teach it in one dimension. I teach with the particle in a box and a particle in a ring, and those are one-dimensional systems. And I teach all of the interaction of light and spectroscopy with those one-dimensional systems. But it's not in the book. And that was my research. Victoria Spin Jackson, who did her master's with me, I said, you've got to make sure this hasn't been done anywhere. And so she went through all the other p-chem books, and it's introduced there, the particle in a box, but it stops at the energies. It doesn't go on to how it interacts with light. Okay. And so only part of it was in the textbooks. And so you'll see particle in a box mentioned in the textbooks, but it stops really short of where we go with it. Okay. So if you're confused why it's not in the book, it's because we teach it in one dimension, and then we use analogies to get to the three dimensions. Because if a mass gets bigger in a one-dimensional system, the energy is crushed down. Guess what happens in three-dimensional systems? The same thing. If angular momentum is preserved in a one-dimensional rotation, it's preserved in a three-dimensional rotation. So these ideas that we get from one-dimensional systems are exactly the same ideas that you have in a three-dimensional system. And so if you learn that one-dimensional system well, with calculus that you know how to do, then you'll be in good shape. I asked a student who went off to graduate school, she wrote on Facebook a few years ago that her quantum class was kicking her butt. And I was like, oh no, is it because of our course? And so I sent her a direct message and said, tell me, honestly, was it because p-chem harmed you? We didn't get into the three-dimensional calculus. And she said, absolutely not. She said, I didn't have Cal 3 and all my other classmates have in grad school. Okay. She said, but because of the analogy way I taught it, she said, I know where the problems are going and they don't. So she knew what the answers were going to be. She just didn't know how to get there. They knew how to get there, but didn't know where they were going. so it was, you pick your poison, right? Anyway. And then now the homework, you'll be a weekly homework quiz here. And then this week's lab will be in Excel. So we'll talk about that in a second. So print your notes. This is a picture of what the homework handouts will look like. They'll have some gaps in them that you can fill out in class. Keeps you engaged, okay? You've already paid for the paper and the ink with your computer fees. So go on in a schedule like the day before or whatever and go to the library and print your handouts there. You can print them 2 per page, or front and back, I guess. 3-hole punch them, put them in a notebook, and you can take your notes that way. It's great. Or some people have tablets and they pull them up and they scroll through and they write on there with their tablets. You can bring those devices if you have them. Each week you click the quiz. It's a printable quiz. This is what it looks like. This is the freshman quiz, but it's what it looks like. You do the problems. Do the problems in a composition book because it's nice and bound. Okay, it's not going to fall apart on you. And then use that. You go and take the quiz on Blackboard, which is really just entering your answers. Okay, so do the work in a composition book. I mean, don't be worried about paper, right? These are cheap. So write everything out, write what you're doing, because you're going to want to go back and study from those homeworks. Okay. And when you have a written problem on the test, I want to be able to see you kind of line it out like you know what you're doing. I can really tell right away when I see somebody's work, whether they've done that problem before or they know what they're doing. Because if it's all scattered all over the place, then I'm like, well, they're kind of just grasping at things. They try it this way and try it that way. That's great. Figure it out. But you really want to be on the test, organized in your thinking, because you're like, oh yeah, I knew this problem was going to be on the test, and you're ready to go. I will give you lots of hints in class of which problems I really think are important. Okay. So where do you go when you need help with the material? Lecture notes and videos, for sure, because I'm pretty obvious in class of what I'm emphasizing. Then if you have those figures and those topics, you can take those, look for those figures and topics in the book. Go to the index, find the words, look for the focus and topic headings, find what we're talking about, and look in those specific sections. The books are written in, quite a lot of detail. It's pretty overwhelming when you look through it. And so get in there, read the text, look for the bolded words, those are your vocabulary words, find the definitions. When you're reading a textbook, it's not like a novel, okay? We train you all in K through 12 to read, like history and literature and so on, but we really don't train you how to read science. And when you're reading science, you have to stop. When you hit a word you don't know, you have to stop and you have to go find out what that word is. And when you hit an equation, some people like me just kind of glaze over and like go past that and do the text. Get a pencil out, write that equation out, and try to figure out what are all those variables. What are the numbers? Why are they using this equation? What is it that they're trying to show me? Because that equation is a whole paragraph. And if you don't actually dig into the equation, you're not reading that paragraph and you're not following what they're saying. So do not do that before you do the notes. Like focus on the notes first. And then, because if you try to read this textbook, page 1 or whatever chapter we're on, you're going to burn a lot of time and you're not going to get done. You're going to run out of time. So it's in those specific sections that you're trying to really nail down. Those are the ones I'm talking about, reading in great detail with pencil and paper. Do this with classmates. Sometimes you run into what you think is a wall and it's just a speed bump. But you don't know the difference. And if you've got somebody there to kind of help you realize, oh, that's just a speed bump, do this. Then you're over it and you're going again. Okay. Please get to know each other and form study groups. Okay. Because if you want me to be your study buddy, I've got too many things that I'm juggling. I can help you on a few questions here and there, very specific questions. Yeah, I can do it right away. But for the long, detailed explanations of things, ask your questions in class so we can really dig into those here and everybody can benefit. Okay. Here's how the grades will be computed. There's an attendance score, 5%. Homework average is 15%. The attendance will be the number of days you signed a roster divided by the max number of days that people have signed, minus 3. So the university gives you 3 excused absences. I don't need any paperwork, no doctor's notes or anything like that. You get 3, okay? 3 can be an athletic event, a doctor, and a car trouble, okay? It doesn't matter what it is, but you get 3 of those, okay? And if there's something that's like long-term or whatever, just keep me informed. Okay, if somebody's got hospital visits, treatments, just keep me informed, especially. Okay, so then homework average is your homework points. That it's not the same every week. Some weeks have 17 or 20 questions, other weeks have 10. And so it's just however many points you get of those different questions, each question is worth 1 point. And then divided by the max homework points. So it's sort of scaled, like if I write an impossibly dumb question or it's got ambiguous answers or whatever and I kill that question, then that point is lost for everybody, but that's okay. We're not, you notice I'm not dividing by the number of things I ask you, I'm dividing by the number of points that somebody in the class got. Okay, so then the lab grade, oh no, this is from the freshman class, I didn't change the slide, so scratch that out. That's why I had this. No. Okay, so this will be from your lab reports, the TA, and so on. I thought, well, nothing's different between the 2 courses, but yeah, lab's very different. That'll be worth 20% of your grade. The lab reports and so on will be due a week after you start them. So if you're on a Wednesday lab, they'll be due the Tuesday night at midnight before your Wednesday lab. Sometimes I've had it due right before lab starts, but then people are trying to cram it into that lunch hour right before 1 o'clock, and they'll bleed into the next lab, and so they won't be doing the next lab when the next lab's supposed to start. And that's a bad practice, because then you start getting behind and start messing things up on the next lab, and the dominoes start to fall. So whatever day your lab's due the night before by midnight or 11:59. There is a late policy that is an exponential decay. Okay, so let me talk about this. So I always hated it. You know, you're sitting here, you're sitting at 100% possibility, right? And here's the time it's due. And some people say, well, you know, if it's late, you lose half points or something like that. And now it's 50%. So even if you had like an 80, now you got, you know, you're capped at 50. And that's a lot of pressure to put on that 1 minute. Right, when you're uploading to Blackboard and you're like, come on. Right. And so I just don't like step functions, and neither, you know, typically nature doesn't either. And so we use an exponential decay. Okay, and the half-life is 24 hours. Okay, and so you can figure that out, the equations in Excel. So if you're an hour late, okay, so you put it in at 1 a.m. No, yeah, 1 a.m., you know, night before it's due. The loss of points is really not much. Okay, so if you're looking at that and you're like, I just need a few more minutes, right? I'm going to put it in. It'll be late. Okay, the TA will look at the time in which it was submitted, and it's okay. They'll calculate, you know, the scaling factor. So whatever grade you get will then just be scaled by that 0.95. And you'll get 95% of what you submitted. Okay, but it may be worth it. Like if you're writing that conclusion paragraph or answering those last 2 discussion questions, that gets you 20 points more, and you're going to lose one of those points because it's late. But it's better to spend that hour finishing out those last 2 discussion questions and getting those 20 points or whatever it is, and then so it's up to you. But that way there's not this step function, and people calling me at 1. I submitted it, I promise. Yeah. Then the exams, we have 5 exams, and they're going to be all equally weighted, and that'll go into your exam average. And then here's your overall weighted average. And so whenever you're trying to figure out what it is, what you need on the final to get the such and such weighted average, you're going to have this score, you know that, you know that, you know that, you will know these 4, and so that's your variable. And so that's a great math problem. I've never seen anybody more motivated to solve a math problem. I will not tell you that. That's the time when you're invested in the result. And so you can do it. Exams for your success, exam tools. We don't lock down your calculator, but it just can't be connected to the internet. So you can use your TI-83 or whatever one is your favorite. But you can't use your phone because it's connected to the internet. You can't use an iPad or anything like that. You do get to use a 3x5-inch note card of equations, and so that's nice. It has to be handwritten. I don't want any computer-generated ones, just because I don't want the building of that note card is really the study tool that I'm after. And so if you've got someone that's making them and then passing them out, you know, then you're not going through that learning exercise of deciding what goes in your go bag, right? Your note card. You're taking that into battle. What goes in your backpack? And so those are your favorite equations, and that's always fun to see. I always look at them to see if they're not computer generated, but I always like to see how small you can write. Highlighted colors and everything like that. It's really, really creative, and it's nice, yeah. And then the exams we'll have a multiple choice section to help me get through the grading quickly. So bring this kind of 882E form. They have them in different places on campus. Attendance policy, you just sign the roster. I'll check that in. Ways to screw this up is forgetting to sign the roster. If your signature's not there, no credit. Even if you were here, it's not a big deal. It's 1/40th of 1/20th of your final grade. Okay. So it's not a lot of points. Okay, so don't freak out, and don't sign for someone else. Don't lie. I mean that harms your reputation really badly. And so don't burn your reputation over 1/40th of 1/20th of someone's grade. Okay. Oh, yeah, and you get 3 free absences. If you plan for exams, if you have an unreliable vehicle, have a friend on call. It's like, hey, dude, I need a ride. Okay. If you're fairly close, like in Huntsville, they have cabs. Okay. I'm saying try your best to get here. But if you just can't, if you're sick or whatever, telephone me, leave a voicemail, send me an email or whatever. Try to take it as soon as you get to campus. If enough time has lapsed, or especially if, if too much time has elapsed, then I may negotiate with you that your final would count for that missing exam percentage. But that just doubles the weight of the final. And so it's it helps, but it can also hurt. And then academic dishonesty. Unfortunately, this is the course where I've seen the most cheating on the lab reports. And it's starting with someone else's lab report. Turnitin is amazing. It shows me where your source of information comes from. And all the previous reports are in Turnitin. And so I can see when somebody started with someone else's report, because like 30% of the report is the wording from someone else's report. Yeah. And so that's not good. And we've had people fail the course because of that. So don't. It's a pretty tight definition. The textbook definition of plagiarism is 10 consecutive words. Yeah, 10 consecutive words from a source that's not cited or quoted. Okay, and you're not going to cite the person from last time. That's right, as so-and-so had in his report. So that's a pretty tight bar. So just don't even give yourself that temptation. We're not really looking for long, flowery speeches about the topic. We want to see your discussion questions, and the introduction and theory is going to be very, very sparse. We're not looking for long. Length is not an issue. It's you need to show us, one, you can write, and two, you're trying to convince the TA that you understood what was going on in the lab and that you learned something. Okay, so that's the purpose of the report. Now, let's get ready for Wednesday. What do we got to do? Okay, download the handouts, okay, and print those at the computer lab. Read chapter 1, and it's pretty short. It's like 10 pages, and double spaced. Okay, so really 5 pages. That'll give you an idea of what we're doing in this course. And then the lab work this week. You've heard the course is heavy in Excel, okay? So I made an Excel boot camp, and the playlist is linked there on Blackboard. So if you go there, pull up a spreadsheet, watch those videos, pause the videos, try it on your own in your spreadsheet. So I want to see you try some things in the spreadsheet, anchoring cells and stuff like that. You can put some little words in there, say this is my little anchoring cell exercise, I anchored whatever. So you just talk to the TA in that spreadsheet. They're going to look at them. There's really no structure to this assignment. It's just what you did to help practice along with those videos. So watch those bootcamp videos, practice some of the techniques. There's some matrix multiplication. And so get in there. You can have that as a sheet. You create new sheets at the bottom. You can say matrix or whatever for the sheet label. The more organized your spreadsheet, the better, right? And so show the TA. I mean, it doesn't have to be perfect and like a beautiful poster with all kinds of, decoration, but just be organized. Okay. And you're graded on 3 criteria. Is it complete? Is it correct? And is it clear? So clarity, so that's the labeling of the assignments and telling the TA what you're doing and where you're doing it. Is it complete? This one, complete, is just turning in the Excel sheet with your practice. And is it correct? And there's really not any correctness on this. We're not grading any particular task. But in other labs, there'll be, are the discussion questions complete? Are they correct? And are they clear? And clarity includes writing. So, your writing score is buried in that clarity piece. So that's the rubric. And it's got a few questions, or a few minutes for questions. So is there anything I can clear up for you now? And I really want you to ask your questions in front of everybody, because everybody will benefit. I guarantee your question probably 3 other people have. So go ahead. Yes.
The questions, like the practice problems in the book, are there answers in the book too, so we can practice on them?
I think that there may be half of them. I don't know if it's the evens or odds, but I think there are some answers in the back for half of the questions.
Okay.
Yeah. Yeah, and there's a lot of types of questions that we can't get to. So it's not very satisfying. If you have a question about a problem that you're interested in the book and it's not something I'm going to test you on, I'm going to tell you that. But that doesn't answer your question, right? You're like, but I want to know. And I'm like, okay, but we can go through it, and it may be a problem I haven't done in a long time, so we may have to hack through it together, okay? But I'll tell you early on, and you can make the decision: do we proceed or not? Right? It's like, well, that's a ancillary. We can look it up together. Yeah. Other questions? Yes.
For the book, for the questions, do you have like recommended questions or problems that we can do that way? We're not like wasting time.
I haven't done that. I try every once in a while, but just go with the similar terms. So like whatever you see on the regular quiz questions, look at those same kinds of vocabulary words. And so if you're scanning through the problems and you see like Boltzmann distribution or something like that, you're like, okay, that's probably one that's related to what he's talked about in class. So that's why I said the book is second. The notes and videos are first, and those homeworks, and then the book will help you with those. Yeah. Yes.
So, is it okay to say that you probably won't put the book questions?
Correct. I'm going to try to write, I write the exam from those homework quizzes on Blackboard. So since they're weekly, we have an exam maybe every 2 weeks or every 2.5, 3 weeks. And so there will be, around 20 to 30 questions I can choose from those, or things from the lab. I'll pull in some figures from the lab or figures from class and ask you about those figures. So there'll be some vocabulary questions, some figure questions, and some problems. And so lecture notes and homework quizzes are where the exam material come from. I really want you to go into the exam confident. If you know why it's right on those quizzes, and you're following the lectures, and you've watched a few of the videos, and you've asked your questions about the figures, then I think you should be able to go into the exam with some confidence. That's the other thing that really is the soft skill of a scientist. It's not just knowing what to do, but having some confidence. And so competent confidence or confident competence. That's like the golden standard. If you can be competent and confident, not arrogant, just confident. You know something, and you're ready to talk about it. All right, we'll see you Wednesday. Oh, I'm sorry, one more.
I just wanted to ask, so it's been about a year since I've taken calculus.
Yes.
What should I do to kind of get refresh my memory?
You don't really have to worry about it. So the TA, you have 4 hours with the TA to kind of refresh.
Okay.
In next week's lab.
All right.
Yeah, good.
Thank you.
Yeah.